Dear students, welcome to CR's digital classes. Today let us discuss about combination. So permutation combinations we have learned earlier in probability. Let us discuss again how the permutation and combinations goes on. Particularly in this session, let us discuss how combinations will go on in probability. So here is some definition and how it goes on. Let us check it out. So a combination refers to the selection of objects irrespective of their arrangement. So what they are telling here, selection of objects will be doing irrespective of their arrangements. Means we have in our hand whatever you want to arrange, you can go on. So that's what is a combination mean. Like I have 10 set of balls, different colors of balls. I want to rearrange them. So there is no rule that a particular thing first and then two colors together, three colors together, like that. It's my wish. Whatever I want to arrange into combinations, I can go on. So that is the actual combination. Now we have different ways to that, and we have some formulas also. Let us check it out. So the number of combinations of objects in different ways entirely different from the number of their permutations. So in permutations, I'll explain clearly what are they, what are permutations actually. And now let us completely concentrate on combinations part. So the total number of possible combinations of set of objects is always taken as 1. So overall possible combinations will consider as 1. Obviously we are discussing under probability. So probability always goes to 1. So here also all the possible combinations, if you consider, that entire thing goes to 1, they are telling here. Now, for example, the possible arrangements from the set of objects A and B are AB one set and BA another set. Arranging together, arranging A I have, B I have. How to arrange? Simply two ways you'll get. That is AB combination, BA combination. That's what is an example here. Irrespective of their order, AB is same as BA. So just now we discussed, right, there is no rule that how to arrange and all. So order is not required, like first AB should be or first BA should be, or they are equal or not, like that we don't have. Simply we can arrange them in our requirement however we want. So first we can consider AB, then BA, or BA, then AB. So that's what here they are mentioning. So there is only one possible combination for this set. So that's what only this AB and BA combination we can consider. Then the number of ways of selecting R objects from n different objects irrespective of their arrangement is called combination. Now instead of AB, generalized formula we are considering, that is some R objects we are considering, and I am arranging that R objects in n different ways. So how the formula goes on, let us check it out. So it is denoted by NCR. So the NCR is a combination, C is for combination notation. So N, C, R we have to consider. N is different combinations, R is different objects. Okay. So how to expand that formula also they have given here. Let us check it out, that one. We have to spell this as NCR. NCR is equal to n factorial. Check it out. Exclamatory mark we call in English, right? So that one we have to consider, and we call them as n factorial. If you are considering for n factorial divided by r factorial into n minus r factorial. So this is the formula for combination. So whenever we want to arrange some of the values or variables or objects in a different combination, so we consider this combination formula, that is NCR formula. So this is your formula. Again, NCR we have, we can consider them in how to consider also we can discuss. Now let us check it out how it goes on here. Each combination of R objects which can be arranged in R factorial ways, means R objects I have like 10 balls, just now I said, no. So 10 balls I have. How to arrange them means if you take factorial to that, we'll get its different arrangement. So R factorial ways give rise to R factorial permutations. So here permutations also will be arranged. Permutation means one particular thing, how to rearrange again and again with other combinations, that is your permutation. So in permutation combinations together we have the formula. So hence permutations of each of the NCR combination yield NCR permutations. So NCR we can consider into permutations also. So formula goes like this: NCR into R factorial. NCR just now we discussed, whenever we want to arrange into combinations we'll take NCR. Now if you want to convert into permutations, what we do is NCR into R factorial you have to consider. R factorial is arranging R objects into different ways. If you take R factorial, it is possible. So NCR into R factorial goes to NPR. So permutation, this becomes a formula for us. So now let us check it out. Final formula. So NCR becomes this one, n factorial by R factorial into n minus R factorial. So with the combinations of permutations, if you consider, this one becomes a formula, and only NCR if you consider, this is the formula. So this is how we'll take the combinations, permutations. This formula you have to consider. If definition they ask, this way you have to follow. If they ask any of the problem to convert, to give different combinations of that data, simply take this formula, substitute the values and get the answer. And one more, how to expand the n factorial also let us discuss. Like n factorial I have, n factorial means what we do is, first n will consider n into n minus 1, means one value you have to subtract from that original value. Again you want some more, means n minus 2. For again some more value you want, means n minus 3. Like that it goes on. Here I want to stop, means n minus 3 factorial and stop. So this is your expansion of n factorial we have. Let us take some value and let us try to expand. So suppose for 4 factorial I want to expand. So how to do this one? First n, right? N means 4. 4 into, and then n minus 1, right? So 4 minus 1 into, again n minus 2, right? 4 minus 2 into, like that, 4 minus 3, like that it will go on doing until the last value. So what happens? 4 into 3 into 2 into 1. Up to 1 you have to stop. So 4 into 3 becomes a last value. So 4 factorial expansion is this one. Multiply and get the answer. So whatever number you have, starting with that number, reduce 1 value, you have to go on multiplying. That becomes your factorial answers. Okay, so this is an example for 4 factorial. Like that small value, if you consider some 3 only, so simply I can write it as 3 into 2 into 1. No need of doing minus 1 minus 1 minus 1. It's understood. Less than numbers you have to go on multiplying until you get 1. Like I have one more value, like say 10 factorial I have. What you do? 10 into 9 into 8. If you want to stop at 8, you can stop, but you have to consider factorial here. 8 extension we have. So 8 factorial you can stop. Entirely you want to consider 10 into 9 into 8, 7, 6, 5, 4, 3, 2, 1. Entirely up to 1 you have to go on multiplying. In between you can stop with the factorials. So this is the concept of combination. Hope you have understood this session. See you all in the next session. Thank you.